All right, here are the answers to homework number 5. Check them out. All right, let's work our way through them. Here we go. The graph shows the number of centimeters a particular plant grows, given the point 0, 0, and 4, 6. What is the slope of the line? So I would find the slope. I guess I could use the formula, or I could say I could use the rise over run. The rise is 6. And the run is 4, so it's 6 over 4 is the slope. And 6 over 4 can be reduced to 3 over 2. The slope of this line is 3 over 2. Even if you use the formula, it would be y minus y over x minus x, which is still 6 over 4, right? What is the rate? So the slope is the same as the rate. I would go ahead and divide this number. 3 divided by 2 is 1.5. I just need to put the units on, and the units are centimeters per week. This plant is growing at 1.5 centimeters per week. Number 2, between the time and the number of soda bottles a machine can make, what's the slope? So I would pick a couple points, and I would do rise over run. The rise is 50. The run is 2. So the slope is 50 over 2, which equals 25. And the rate would be the same as the slope, right? Rate and slope are the same, so the rate is 25. I just need units. And this would be the number of soda bottles that are made each minute. So 25 maybe bottles per minute. So I include the units. Number 3, the points 15, 21, and 25, 35 form a proportional relationship. Find the slope of the line through these points. All right, well, I can do the slope first. Let's go ahead and do the slope. So for the slope, I'm just going to go ahead and do the formula. 35 minus 21, 25 minus 15. That would be 14 over 10. Or 2 goes into both, that'd be 7 over 5. Looks like I got that one wrong on the answer sheet, doesn't it? So the slope would be 7 over 5. I think I put 7 over 2. And which is the graph? So it's definitely not this one, because this one is not proportional. It's one of these, and I guess I could just look and see where this point is. Let's see, in A, my x's, 1, 2, 3, 4, 5, 6, they're going by sevens. That's 7, 14, 21, 28, and so on. And the y's are going 1, 2, 3, 4, 5, 6 by 5, so that's 5, 10, 15, 20. And so on. The point 15, 21 would be like right here. Well, that's not on the line. It must be graph B, but let's check it anyway. Here it looks like the x's are going by 1, 2, 3, 4, 5, 6 by 5s. That'd be 10, that'd be 20 and 30. And it looks like the y's are going by 1, 2, 3, 4, 5, 6 by 7s. So that'd be 7, 14, 21, 28, and so on. And the point 15, 21 would be 15, so right there. So this one is the correct graph with a slope of 7/5. Okay, number 4. Kenny burns 117 calories in 13 minutes. There is a proportional relationship. So the unit rate would be, let's see, I've got one XY point here. 13 minutes, 117 calories. That'd be 117 divided by 13, which is 9. But since this is a rate, I need units. So it'd be calories per minute, right? And which graph is that? Well, again, it's proportional, so it's not this one because it doesn't go through the origin. It's got to be one of these. 9 per minute, so let's see, this is going by 9s. This is going by 1s, so it looks like 1 minute, 9 calories, 2 minutes, 18, 3. This is clearly the graph. And all I did was look and see which graph is going 9 calories per minute. Number 5, the graph represents slowing. Find 2 points on the line and use them to find the slope. All right, the easiest 2 points I thought were this one, which is the point 0, 310, and this one, which is the point 10, 0. I thought those were really easy to find the slope, whether you use the formula or the rise over the run. If I use the rise over the run, this would be down 310 over 10. So it'd be negative 310 over 10, which equals negative 31. And what is the rate? Well, the rate is the same as the slope, so it's going to be negative 31. But I need units, and these are really interesting units. The units here are meters per second, and the units down here are seconds. So the fact that it's negative means that it's slowing down. So instead of writing negative, I'm going to write slowing down 31, and it would be meters per second per second. That means every second it gets 31 meters per second slower. Think about driving a car. You'd be slowing down in miles per hour, right? Every second, maybe you'd slow down 10 miles per hour. Number 6, the graph shows the relationship between temperature and an object being heated. What's the slope of the line? So it looks like there's a good point here, and of course here and here are marked. And if I was going to do the slope, I would do the rise over the run. Notice that the y-axis is going by 4s. So this would be 4, 8, 12, a rise of 12. The y-axis is going by halves. So it'd be a half, 1, 1 1/2, 2. So the slope would be 12 over 2, which is 6. And the rate would be the same as the slope, so 6. But the units would be degrees, let's see, degrees Celsius per day. So it is heated 6 degrees Celsius per day. It's going up by 6 degrees per day. Number 7, assume that car X and car Y both traveling. Car X is going 186 miles in 3 hours. So that is 62 miles per hour. I need to find the graph that is going up by 62 miles per hour. Well, I don't think it's this one because it doesn't go through the origin. This one, let's see, is going by hours down here. 213 divided by 3. 213 divided by 3 is 100, and what is it? 210 would be 70, 71, 142. So that's going up 71 miles per hour. That's not it. It must be graph C. 248 divided by 3, divided by 4 is 62. Yep. So this one is going up 62 miles per hour. It is graph C. And as far as car Y goes, car Y is traveled 142 miles in 2 hours. That is 71 miles per hour. So I need to find the graph that is going up by 71 miles per hour. And let's start with A over here. The hours are going by ones. Let's see, I need to divide that by 3. 213 divided by 3 would be 71. So in fact, this one is going up by 71 miles per hour. Graph A is the correct graph. And that brings me to question 8. You need to hire a DJ for a party. The DJ charges an initial hourly rate. An initial plus an hourly rate. The graph shows the relationship. What's the slope? All right, if I want the slope, I need to find some points. This is a good point. Look at that. At 0 hours, you're already paying $200. That would be like his initial fee just to show up. And then it looks like this is a good point, and this is a good point. So I'm going to find the rise over the run. I'm going to go ahead and make my triangle. Now again, you need to pay attention to the scale. On the y-axis, it is going by 50s. So this would be 50, 100, 150, 200. The rise is 250. The run is going by halves, right? So a half, 1, 1.5, 2. The run is 2. So the rise over the run would be 250 over 2, or 125. The slope of that line is 125. And so the rate would be the same as the slope. It'd be 125, and the units would be dollars per hour. He charges $125 per hour. That would be his rate, $125 per hour, right? And last up, number 9. The graph shows the relationship between the number of minutes an airplane has been in the air and its elevation. Use these points to find the slope. All right, so I would do y minus y over x minus x. And when I go ahead and subtract that, 6664 minus 4165 gives me 2499 over 1.5. And if I divide that, I get 1,666. The slope of this line is 1,666 using the slope formula. Y minus y over x minus x. And then I need to explain what that means as a rate. So the rate is the same, I just need to put the units on. That's feet per minute. It sounds like the plane is going up at 1,666 feet per minute. So plane is rising, because it's positive, at 1,666 feet per minute. That seems pretty fast to me. I wonder if that's accurate. All right, hope that helps.